In this video, we're going to be talking about evaluating perfect squares, not just with numbers, but also with variables. So we know from previous videos that the square root is the undoing or the inverse operation of squaring. So we have to figure out what is being squared. So in this case, we are asking the question, what times itself would give me 25? Well, 5 times 5 would give you 25. So the square root of 5 squared is 5. Just like that with variables, the square root of x squared is just x, because x times x gives you the x squared. So let's go ahead and look at some of these examples. On the left-hand side, we have the square root of 81 squared. So what times itself would give you 81 squared? Again, you can think of these as undoing one another. If I square it and unsquare it, I'm just left with 81. Alright, what if I have a different power other than a 2? Here I have the square root of 7 to the 6th power. What times itself would give you 7 to the 6th? So with exponents like this, we have to think, well, exponents rules. If I had x times x, I would get x squared. If I had x squared times x squared, again, something times itself, I get x to the 4th. X cubed times x cubed, I get x to the 6th. Do we see a relationship between what is being squared and the result? Right? The rules of exponents say we add. So 1 plus 1 gives me 2. 2 plus 2 gives me 4. 3 plus 3 gives me 6. 4 plus 4 gives me 8. So to go backwards to figure out what times itself gave me this value, we just have to cut it in half because it's going to be 2 of the same value. So if I want to know the square root of 7 to the 6th power, well then it must be 7 cubed times 7 cubed gives me 7 to the 6th. So 7 cubed is being squared, right? And you can also use the power rule here. 3 times 2 is 6. Gets us back to where we started. Now, that square and square root undo each other. So I have 7 cubed. And depending on how your homework wants you to leave this type of problem, you might just leave it as 7 cubed, or you could actually evaluate it. My guess is a problem like this, you would leave it in that form, just showing that the square root of a power other than 2, you take it and divide it by 2. You cut it in half. Same thing with this square root of x to the 12th. X to the 12th, I want to undo it. I cut it in half. So what is being squared? X to the 6th is being squared. Right? 6 times 2 would give us that 12. And now it's x to the 6th times x to the 6th gives us x to the 12th. So we have a square, we have a square root, we're undoing that square. The answer is just x to the 6th. And I want to mention that this is assuming that the variable represents a non-negative value, a non-negative real number. Okay. Go ahead and try the examples on the right-hand side. Alright, first example, I have the square root of 4 to the 10th power. So I'm asking what times itself would give me 4 to the 10th. So I take that exponent and I cut it in half. Because with the exponents we would be adding, so I need half of that. That would add to itself and give me 10. So 4 to the 5th squared would give me 4 to the 10th. So now I am squaring 4 to the 5th, I am unsquaring 4 to the 5th, and I end up with just 4 to the 5th power. Okay, don't try to take the square root of 4. I've got all of these 4s. I have 10 4s being multiplied. So in this case, 4 is the base. It is not a value that you should be taking the square root of. We have to deal with this exponent first. Alright, next example, square root of a to the 8th. Again, I can just cut that in half. So a to the 4th, 8 divided by 2 is 4, is being squared. I can check it. 4 times 2 should give me the 8 I started with. And then I square it, I unsquare it, or take the square root, and I get a to the 4th power. Right? Squaring and unsquaring, or squaring and square root are inverse operations. And again, that's assuming that this variable a is a non-negative real number. Alright, square root of m to the 14th. Cut it in half. I'm going to skip this middle step and just say the answer is m to the 7th, right? 14 divided by 2 would be 7. So m to the 7th times m to the 7th should give me m to the 14th. Alright, let's look at this next one. It says the square root of negative 3 squared. And I said be careful. Okay, so let's talk about this. A lot of the times students think the answer is negative 3. Right? So you have your square, you have your square root. The answer should be negative 3. But notice as we went through these, I mentioned that we have to assume the variable is a non-negative real number. Well, let's look at this a different way. So I'm going to scratch this out. Don't do that. Let's follow the order of operations. So if I had to simplify this and I didn't actually want you to take the square root yet, I wanted you to simplify that square first. If I squared negative 3 times negative 3 is actually a positive 9. And what's the square root of positive 9? Well, 3 times 3 would give me 9. So that square root is actually positive 3. So when I say that they're kind of undo each other, again, it's only for if that value is a non-negative real number. If it's negative, you have to kind of evaluate it first and then simplify the result. Okay? Let's look at a couple more. Now I'm throwing in coefficients and variables. We have this rule that says if I have the square root of two values with the same index, I'm going to talk about indexes later when we talk about cube roots and fourth roots and things, then you can, and they're being multiplied, you can bring them together under the same radical and multiply them there. In the same fashion, if they started under the same radical and it's quantities being multiplied, so factors, you could break up those factors and take the square root of them separately. Okay, so you can go back and forth, back and forth. So when I look at the square root of 81c to the 8th, I could actually rewrite this as the square root of 81 times the square root of c to the 8th. Right? I can break it up. This is multiplication here. It's still multiplication when I break it up. And then take the square root of them separately. So square root of 81 is 9, because 9 times 9 would give me 81. And the square root of c to the 8th is c to the 4th. I take that exponent of 8, divide it by 2, and check it. C to the 4th times c to the 4th should give me c to the 8th. And so that's how we use this multiplication rule of square roots. We can break up anything that's being multiplied underneath the radical and take the square root of them separately. So for example, this part B, I have the square root of x squared. Well, square root of x squared is x. Again, I'm assuming all of these variables are non-negative real numbers. Next, I have the square root of y to the 4th. Do not take the square root of 4. That's not the idea here. We're taking the square root of y to the 4th power. So again, I use that exponent. I divide it by 2, 4 divided by 2 is 2. So I end up with y squared when I take the square root. Again, because y squared times y squared gives me that value underneath the radical. Same thing with z to the 10th. I take 10 divided by 2. I get z to the 5th power. Z to the 5th times z to the 5th gives me z to the 10th. And that's as far as I can go. Again, once I've taken the square root, I no longer write the square root. Go ahead and try these on the right-hand side. Let's see how you did. Alright, using that multiplication rule of square roots, I can take the square root of all the products separately underneath that radical. So the square root of 16 first. Well, 4 times 4 would give me 16. The square root of a to the 6th. 6 divided by 2 is 3. So a to the 3rd power. I check it. A cubed times a cubed does in fact give me a to the 6th. Next, square root of 49. 7 times 7 would give me 49. Square root of b squared. I square it, I unsquare it, I get b. Square root of c to the 16th. So 16 divided by 2 is 8. Again, don't try to take the square root of 16. A lot of times, students see that perfect square and they want to write 4 here. But the question is, what times itself would get me back to where I started? C to the 8th times c to the 8th gives me c to the 16th. Okay, don't take the square root of 16. You have to think of this quantity all together. C to the 16th power. Next example, square root of m to the 20th times n to the 12th power. Half of 20 is 10, m to the 10th power. Half of 12 is 6. Again, these are being multiplied. This is multiply underneath. It's multiply when we take them out. M to the 10th times n to the 6th. And lastly, I have the square root of the quantity 2x minus 5 squared. Again, we are assuming this is a non-negative real number. So if I square it and unsquare it and assume that it's going to end up positive, then the answer should just be 2x minus 5. Alright, hopefully that gives you a good introduction to taking the square root of perfect squares.